one sun, one world, one grid. That is OSOW. So right now, all these five grids across our country has been integrated, and they are operating at the one frequency. Likewise, they are going to extend to the subcontinents and to the Middle East, and thereby to the African region, and thereby to the Americas. So that we are going to establish one sun, one world, and one grid. So by this way, we are going to transport, or we are going to integrate the renewable energy sources across the grid, across the global countries, and we are going to have the 24/7 of the renewable energy generation. Wherever the excess energy is generated is going to get transported through this one sun, one world, and the one grid concept. So this is the new concept which the countries are proposing. Hopefully, within another couple of years or in a decade, which is going to happen. And when it comes to the electricity, these are all the terminologies related with the electricity. And right now, the electric vehicle is going to get boom like anything, which is going to be an alternate to these conventional vehicles or the IC engines. And again, this is a way of saving our environment, and we are going to stop the emissions, greenhouse emissions, and etc., or the COX emissions or NOx emissions, and thereby we are going to help our environment.
Sir, voice is not audible.
Hello.
Sir, it's audible now.
Hello.
Sir, audible now, sir.
Hello. Vinod, sir?
Sir, it's audible now.
Yeah. Sorry. Okay, sir.
No problem, sir.
Yeah. Slide is visible, sir?
Visible, sir. Clearly visible.
Yeah. Okay, sir. Okay. Thank you.
Okay, sir.
So when it comes to the electricity demand, about 12.6% of the global population is still unelectrified. Lots of these are electrified but get limited hours of supply. And when it comes to the industrial requirement, as per the US EAA, which projects 28% increase in the world energy use by 2040. All these references are given below, and electrification of the transport is a major challenge when it comes to the consumption. So population without electricity, as per the World Bank data, as far as India is concerned, which is 1.32 billion, that is almost 15.5 percentage. When it comes to the world, which is around 12.6 percentage of the people, that is 7.6 billion. In total, around 9 billion people still they are not exposed to the electricity, or they are not having the access to the electricity. So still, if you are going for the electrification of the transport system, means think about the issues we are going to face. And these details are obtained from the World Bank as well as the Energy Information Administration of USA. And when it comes to the energy, as I already mentioned, in order to have the better environment or the eco-friendly power generation, they are relying on the bioenergy or the biofuel, biomass, geothermal or the wind turbine. These are all the renewable energy sources, and wherein we are going to generate this electricity in terms of the isolated locations or at the isolated power generation units, and these sources are going to get integrated with all these grid available at the state utilities or by the central utilities. When it comes to the state utilities, which is going to be taken care by the state government electricity boards, when it comes to the central government, they are going to taken care by the Power Grid Corporation of the India Limited. And the reason for going green is that in India, since a decade ago, depletion of conventional energy sources had begun. Low demand was on increasing trend due to rapid increase in industrialization and population. This has forced researchers to look forward for other sources of energy. That is, the sustainable renewable energy has found as the future green energy solution. So, as I already mentioned, here we are going to have the advantages of alleviating the greenhouse emissions. And when it comes to the finance flow, they are going to have the two classifications. One is the developed nations, another one is the developing nations. When it comes to the developing nations, UNY is going to support us in terms of the weeding out the conventional thermal power plants, and they are going to provide the loans to the state utilities or for the central government organization, such that we can able to get into the newer technologies, or we can get into the newer power plants which are almost on the green concepts. And a worldwide research on deployment of microgrid with the utilization of distributed energy resource is going on across the globe. Probably the European countries are leading in this trend, and Norway or etc. or the German, they are completely relying on the renewable energy sources, and they are completely weeding out the conventional thermal power plants, and 100% renewable energy power generation they are adopting. In context to the Indian microgrid seems to be the future energy solution for economic development, because the government of India is spending crores and crores of rupees or the lakhs of crores of rupees in the energy procurement, that is in terms of the import of petroleum products or the crude oil. So thereby which paves the way for the economic development also. And when it comes to the reliability of the conventional power sources, 80% villages are powering only for 8 to 10 hours per day without quality due to the forced load setting. Probably if we get into any villages, this is the case with respect to the single phase supply or the three phase supply. And again, the reliability of the three phase supply is very poor when compared to these mentioned hours. So again, yet 20% villages are surviving without electricity, being having tremendous potential for the renewable energy sources. So if you think about the hilly region or the desert region or the the poor rain-fed region, we are having this kind of resources, that is the sunlight for around almost equal to 9 to 12 hours, and we are not tapping that energy, and that is the major problem for unreaching these villages. And when it comes to the power capita consumption in terms of the units, India is around 550 units consumption. And when it comes to the world, which is around 1750. almost they are triple the times of the power per capita consumption when compared to the India. And when it comes to the per capita electricity consumption, the figure is around 1,200 when it comes to the India, and at world level is around 2,600. And this is the 2019 strategy, and the 2040, which is going to be projected as shown in the right hand side. So India is slightly increasing, or which is going to get doubled within another 20 years. That is the two decades of the time. So likewise, the generation stations or the generating stations to be installed or the facilities to be improved to reach the doubling of the per capita power consumption by the year of 2040. And why we are supposed to go for the microgrid? So the advantage is that we can go for the remote power system. That means we can go for the isolated power generation, and the resiliency can be ensured at the power grids. So when it comes to the prices of the natural gas and the LCOE, that is in the diesel generator in commercial applications, which is also increasing, and probably with the spiraling cost of the petroleum products or the diesel or the petrol or the allied petroleum products, the power generation cost is almost doubling, and which is not at all imaginable. If you think about an industry which is going to run by a diesel generator set, definitely the feasibility for the profit is very, very lesser. And when it comes to the microgrid, we can able to connect the utility grid, the generator, and the renewables, and thereby we can able to supply the generated electricity to electric vehicles or the residential, commercial, or the industrial applications. And there exists an higher power than consumption, means we can go for the storage also. So when it comes to the microgrid, which is a contained network of energy generation sources and energy storage that are connected to the loads that consume the electricity. The generation can be from renewable energy sources, thus reducing the need to produce energy from the fossil fuels. Thereby, we are going to have the advantages of loss and damage with respect to the environment and to the economic considerations. So we are going to have the adoption finance with respect to the establishment of the grids, and this adoption finance, which is going to support the state utilities as well as the central government organizations in establishing the microgrid with reference to the existing grid. And microgrid is simply an integration of distributed energy sources, that is the power generation, into the distribution, operation, and planning. So any individual or any citizen of the country can able to generate the power, and thereby they can able to integrate into the distribution, operation, as well as the planning. So probably the government of Tamil Nadu already initiated about the net metering, and they lay down certain norms for the integration, and probably that is going to be the future. Each and every household or an residential or an industrial sites or the facilities can able to generate the power, and they can able to integrate it with the existing grid. And microgrid comprise a network of small scale distributed energy resources like fuel cells, micro turbines, PV arrays, and wind turbines, etc. And if required, they will go for the energy storage devices. Probably for another couple of years, it may not required when it comes to the Indian scenario is concerned. And after this lockdown or the COVID lockdown and the industrial shutdown and etc., now the energy requirement or the electricity requirement is increasing at large. And recent times we can able to see the news related to the mining of the coals or the coal mines issues due to the torrential rain, and it's a major challenge for the supplying the coal across the country. And probably such kind of issues will be which will be elevated when it comes to the renewable energy sources or the distributed energy sources. And in Indian context, a microgrid can have several possible applications as to transform the current unreliable power supply to a reliable one. So probably at urban localities, we are not having any problem or we are not facing any load setting. When it comes to the rural side, probably this is the major issue, and they are unable to get the reliable power supply, whether it is for the irrigation purpose or whether it is for the industrial applications or for the household applications. And a village or a cluster of villages can form a microgrid, or university campuses or the institutions and R&D centers can go for the microgrid, or the hospitals, island communities, or large industrial complexes or small townships, they can establish their own microgrid and they can able to monitor their generation consumption and their quality of the supply. They are going to give it to the connected customers to the grid, consumers to the grid. And when it comes to the integration, that is the utility challenge in the integration is that right now we are exposed to the bulk power system. That is the market operator as well as the system operator is going to monitor or control the complete operation of this bulk power system, and then they decentralize it, and they are now they are exploring the possibility for the distribution system, and thereby they are going to establish the master controller and the separate building for such kind of facilities, and this master controller across the microgrid is going to take care of the particular locality exchange the data with reference to the distribution management system. So by that way, we are going to have the distributed generation as well as the consumption, and we are going to integrate the communication with the central system, and we are going to integrate all these operations. And this reintegration, that is the renewable energy integration, focuses on incorporating renewable energy, distributed generation, energy storage, and the thermally activated technologies and demand response into the electric distribution and transmission system. So when it comes to the generation, we are supposed to take care of the grid also. So because grid is a bidirectional system which is going to transport the power on either direction. Suppose if there is a huge generation, means the power can be supplied to the consumers, which may be the industrial load or the domestic loads or the transportation segment. And if it is an excessive power at the other end also, it should be transported to the this generation unit, and this generation unit side also should have the capability of consuming the power. That is the reintegration. So the goal of renewable energy integration is to advance system design, planning, and operation. So this is similar to that of the larger power system network. We are supposed to design the system. We are supposed to have the planning for the next few decades and the operation of the grid on daily basis. And this gives the way for the reduced carbon emissions and emissions for other air pollutants through increased use of renewable energy and other clean distributed generation. Increase asset use through integration of distributed systems and customer loads to reduce peak load and thus lower the cost of electricity, which is going to support this reintegration is going to support achievement of renewable portfolio standards for renewable energy and energy efficiency, and which is going to enhance the reliability, security, and resiliency from microgrid applications in critical infrastructure protection and highly constrained areas of the electric grid. So support reductions in oil use by enabling plug-in electric vehicle operations with the grid. So probably if we are going for the electric vehicle technology with the existing power generation, again, which is going to be a problem of the emissions in terms of the CO2 and the greenhouse gases. And the elements to be considered when it comes to the microgrid, that is the distributed sources, the components are the technical, operational, and the economic considerations. When it comes to the technical, proper control of voltage, frequency, power quality should be ensured, because at any point of time the isolated generation may get into the existing grid, thereby they may create the fluctuation in terms of the voltage, in terms of the frequency, or in terms of the power quality. So voltage means which may rise to sag as well as the swell, and if the power is the energy is generated in excess, means we may have the problem of swelling. But when it comes to the switching of the heavy loads, we may face the problem of sag also. So we are supposed to have the proper control mechanism for the voltage, frequency, and the power, and the protection schemes and the modifications, because the existing protection schemes are meant for the larger system, and we used to operate with the protection system of megawatts or the several kiloamperes of the current, and we are supposed to reinstall, or we are supposed to relook into the protection schemes and the certain modifications related to that one. Change in power flow magnitude and direction. As I already mentioned, the distribution grid supposed to be in the bidirectional one, and we are supposed to reinstall, or we are supposed to relook into the existing protective mechanisms and etc. And steady state and transient conditions. Suppose if we are switching on the particular distributed generation means, or the power generation unit means, we are supposed to study in detail about the steady state and the transient conditions of the islanded grids or the microgrid. And reserve margins, load setting, demand response, and cold load pickup. So reserve margins, load setting, etc. we are supposed to take care, and accordingly we are supposed to give the license or give the permission to operate the generating units. And when it comes to the operational aspect, we are supposed to look into the safety lockout or the tagout system, protection coordination among the generating units across the grid, load to generation matching, because the excessive power generation may turn the state utilities into the red. And the load imbalance at the particular locations, we may face this load imbalance, microgrid communications, monitoring, and dispatch. So these factors supposed to be considered among the microgrids. There should be a proper communication among the grids of the particular locality or at the particular geographical location. Monitoring and dispatch of the generated power is also an important aspect. And the ongoing maintenance, probably again this may rise into the big picture, because the maintenance means the existing larger networks completely shutting down the particular substation or the particular grid. When it comes to the isolated generation or this microgrid, we are supposed to take care of the maintenance of the ongoing or the power supply too. And when it comes to the economic considerations, microgrid and non-microgrid customer impacts, because probably if it is going to be a microgrid means, for smaller loads it won't be an issue or a threat. When it comes to the larger industrial loads, definitely which is going to be a brainstorming one. And when it comes to the balancing of the cost versus reliability, again, if it is going to be an heavy investment means, again the balancing of the cost is going to be the problem, and probably the reliability issues when it comes to the complete reliability with reference to the sunlight. And lifespan of the installed system, probably right now the solar PV installations, they are promising around 25 years. We don't know how we are going to progress on this front. Probably the technological advancements will save such kind of issues. So the other microgrids, the weather forecast, energy markets, etc., supposed to be taken care, and thereby we can think about whether we are going to switch where we are going to switch on to the conventional system or the microgrid. The characteristics of the microgrid are as listed, which is going to be on distributed resources and load, obviously, because thereby the concept of microgrid is arising. Ability to disconnect and parallel with the distribution system, And this is the important advantage when it comes to the microgrid characteristics. We can able to disconnect it at any point of time, provided if there is no critical load, and we can go for in parallel with the distribution system. And the intentional and planned islanding is possible, because the isolated power generation can be can be shut down at any point of time if there is any larger fluctuations, or there is a larger disturbances in terms of the voltage, current, or the power quality. Means we can go for the planned islanding also. And the issues in the reintegration, the various typical issues in renewable energy integration are as listed. Data and forecasting, because due to the weather conditions, we are unable to forecast the power generation. The data available with any network is not an reliable one. Scheduling, flexibility, and incentives, because right now the governments are offering incentives for the renewable energy generation or the penetration of the renewable energies. We don't know how long we are going to get it, such kind of incentives, because in the late 90s the windmills used to get the huge quantum of the incentives or the subsidies for their power generation or the installation. But recent times again they reduced it, and probably now they are focusing on the solar PV systems, that is the SPV. And probably in the last 2021 March 31st also, they had a deadline related to these incentives. And they had market participation and reliability commitments, because all these microgrids are operated with respect to the particular geographical locations. We don't know how we are going to sell it in the power exchanges, or how the individual generators are going to sell it to the power traders in terms of the national power exchange. And the balancing authority coordination, if it is an state utilities or the central government organization, central government power authorities, the hierarchy is well defined. And when it comes to the integration of these renewable energy sources, that is through the microgrid, again the authority coordination is going to be a major challenge. The reserve products and ancillary services, with reference to the failure of the sunlight or the failure of the particular unit or the capacity, particular installed capacity, again we are supposed to think about the reserve products and the ancillary services. The capacity markets relevant to the photovoltaic generation or the renewable energy generations, and the real-time adjustments. Again, this is going to be a major challenge when it comes to the renewable energy integration, because this renewable energy integration, if it is going to be a very little load or of kilowatt capacity, it won't be an issue. If you are thinking about the megawatt capacity, definitely which is going to be an issue. And probably we know that with reference to the recent quotations made by the renewable energy giants, they are going for the sub 2 rupees category also. Right now the companies are ready to offer the electricity per unit at the rate of 1.98 rupees or 1.65 rupees. So the real-time adjustments need to be taken care. And comes to the renewable energy sources are the location specific, because renewable energy generated electricity may need to be transported over considerable distances, and this is a bit supported with reference to the existence of the national grid, and the private players such as Reliance, the Adani, or the the government utility, the Power Grid Corporation is taking care of the generation and the transportation of the renewable energy, the transportation of the renewable energy generated power. And beneficial combinations of renewable energy sources may not always be practicable, because countries such as our nation, definitely we are facing these issues. And if you are going for the European Union or the European countries, again this is a major problem, because they are not having the equal duration of the day and night. And the lack of flexibility, which is a major threat to this renewable energy integration, that is the balancing supply and demand, uncertainty in predicted output, because the power generation is completely dependent on the climatic conditions, either wind or the for solar or the geothermal power stations, we can't able to predict the next moment or the next minute. And the mitigating measures in renewable energy integration is that flexible generation, auxiliary services, reserves, etc. for supply balancing, demand side management, demand response, and storage for load balancing. Strong grid integrations will help these issues related to this renewable energy integration. And the forecasting of renewable generation and forecasting of demand supposed to be improved. Establishment of the renewable energy management centers. So right now we are having the load dispatch centers across the nation or across the state. Like that, we are supposed to have the renewable energy management centers. Thereby, they can able to manage with the generation, the utilization of the renewable energy. And we are supposed to go for the advanced forecasting tools along with the reliable communication infrastructure. So probably the communication technology has been improved a lot. When it comes to the forecasting tools or the technology, still we are struggling for the forecasting of the power generation from the renewable energy sources. And the deployment of the synchro phaser technology, that is the phaser measurement unit, and the wide area monitoring system on pooling stations, and interconnection with centralized control center through fiber optic communications for real-time information monitoring and control. Again, if we are providing the PMUs or the VAMs, so that we can able to alleviate the issues related to the synchronization of the isolated sources. Institutional arrangement with the defined roles and responsibilities of various agencies, generation, developers. So again, as I already mentioned, the clear demarcation of the roles and responsibility among the government agencies and the private agencies will give a good way for the renewable energy integration. And technical standard requirements such as grid code, connectivity standards, real-time monitoring, etc. should be monitored. And again, probably right now they are providing the standards by the IEEE. And again, we are supposed to go for the nationwide or the nation-specific technical standard requirements for the renewable energy integration. The policy advocacy for development of power balance market and pricing mechanism, because due to this decentralization or the decentralized power distribution units or the generation units, probably the pricing mechanism will be an issue. Again, we are supposed to have a balance, or we are supposed to strike a balance between the generator as well as the consumer. And when it comes to the standards, there are several standards specifying various aspects, grid integration of local power generation sources. Arguably, the most important one is the IEEE 1547. So in this, they are having the standard up to 0.8, that is 1547.1, 1547.2, 1547.3, 1547.4, and 1547.5, 6, and 8. So out of these standards, certain standards has not yet issued for the general usage, whereas still it is in the research level. So the first one, IEEE standard conformance test procedures for equipment interconnecting distributed resources with electric power systems. And the standard 2 is meant for application guide for IEEE standard 1547, IEEE standard for the interconnecting distributed sources with electric power systems. So likewise, physics standard is meant for the specific utility or for the grid. And the microgrids, when it comes to the operation, the methane emissions by 2030 can be reduced by 30%. Thereby, we can able to reduce the ill effects of these carbon emissions and etc. So by that way, yeah, sir, just a minute. Sir, சொல்லுங்க. ஆமாம், சரி. சரி சரி ஓகே சரி நான் ஈவினிங் வரட்டுங்களாங்க சார் கூப்பிடுறேங்க தேங்க்யூ யா So thereby we can go for the reduction of the methane emissions 30% by 2030, and we can think about the loss and damage both for the economic conditions or for the environmental conditions or for the economic conditions. So that is the advantage of going for this microgrids. So multiple distributed resources controlled as a single entity with respect to the grid. So as I already mentioned at the beginning of this presentation, the whole world is thinking about the one sun, one world, and one grid. So thereby, if we are integrating all the distributed generation stations or the distributed energy resources, we can think about the single grid. So with respect to the grid codes, we are going to follow the voltage level, the frequency level, and the other parameters related to the power quality issues. But they can be more than that of a fundamental shift in the way that the electric grid is built, operated, and financed. Because right now, as far as Tamil Nadu is concerned, only one microgrid is approved at the Tirunelveli, and that too only for the particular location of the particular industrial estate. So if many of the players, that is the private players, are coming into this microgrid, means again we are supposed to go for the grid building, operation, and the finance. And right now the Power Finance Corporation or the state government or the central government is supporting all the power projects, but this is not the case for the future planning or the implementation. And a threat or opportunity to utilities depending upon how the transition is going to occur. Definitely similar to that of the private communication providers, that is the cellular providers. This is going to be a threat as well as for the opportunity for the certain corporate giants, and they are going to have the both pros and cons depending on the transition which the government is going to guide. And the pros and cons of the microgrid is the opportunity or the value is absorb renewable intermittency at the source. That means if at a particular geographical location the energy is abundant, means which is going to get transported to the other end or the other side of the particular region. Avoided cost benefit, low cost ancillary services, demand response, more resilient grid, new value added services from utility side. So if we are having the good number of electric vehicles and the electric vehicle penetrations, we can go for the new value added services from the utility side. That is at the generation station itself, we are going to establish the charging stations, and we are going to interconnect it through the microgrids and thereby to the larger grids. And the cost or the risk are as listed. Revenue reduction, the demand and kilowatt hour reduction may be there. Negative power system impacts, definitely, which is going to impact the larger power networks, and they are operating decades and decades continuously, and probably this is going to have the greater impacts. And the utility customer disintermediation. So probably there won't be any state utilities or the separate entity for such kind of this intermediation. Higher cost if we passively manage DG on the grid. So probably if the power generation is done through the DG set or the cost tier system, definitely the cost of the operation with reference to the particular grid is going to be higher. Goals of the distributed resources and the business model, the objectives and the desired outcome are as listed. Ensure designs and operations are grid So that means the existing grid should not be affected or the utilities should not be affected. Second one, provide incentives to cooperate. That means like the farmer cooperatives or the other cooperatives existing across the country. Here also, the for power generation, the cooperatives are going to be generated and benefit both parties. That means cooperation. That means both the generator as well as the consumer is going to get benefited. New value add growth opportunity. That means these renewable energy source integration or the distributed resources are going to give the new services both for the manufacturing sector and for the existing utilities. So the options for the utility and grid are as listed. When it comes to the distributed generation, we are going to completely rely on the first two, that is the solar and the wind. And the fuel cells are coming up in a little way. Still, researchers are working on it. And the energy storage, the reduced bills are going to be the advantage. Increases the reliability when it comes to the smaller hamlet or the locality. Provide capacity services. That means need not go for the larger generations or the thermal stations of 10,000 megawatt, 20,000 megawatts, and etc. Provides energy arbitrage, which is going to be an added advantage. After meter services, that is the demand automation. The scope for the demand automation is there. Microgrid solutions, that is the power quality is going to be ensured by the particular facility. Reliability is going to be ensured due to the various and the little quantum or lesser size of the power generating stations, and which is going to be a cost effective alternate to the grid expansion. We are all aware about the grid expansion and the running of the grids for the longer ranges or across the farmlands. And the opportunities for the utility side supports the integration of renewable energy sources at micro level, improves the reliability and power quality, provided all the inverters or the connected power electronic converters are going to be the approximated output or the sinusoidal generation. Support emergency operation, and if there is any issues with respect to the larger grid means we can go for the microgrid. Ability to ride through outages, that means we can able to manage the outages of the power at certain point of time. Optimize energy usage, so which is going to optimize the energy usage means we can able to optimize the energy usage in terms of the operating efficiencies. Enable participation in new markets for demand response and ancillary services. So this will give the way for the new markets for demand response and ancillary services. So any individual industry or any individual company can go for the power generation, and there will be a scope for the new markets and for the demand response and ancillary services. The utility of the future, e-platforms creates an opportunity for customization. Third parties may develop their applications that target services similar to that of the cellular services. Utility grid will do the same. Some customers may want a DG or EV or the distributed storage, depending on the requirement and their capability in terms of the finance and the facility available. They can go for the DG or the EV or the distributed storage, and probably the reliability with reference to the petroleum product based power generation can be elevated. Some may want to sell service to the grid, want to provide the isolated generations like the cellular service, that is the particular cell service to the grid, and some need community solar, and probably which is going to happen in terms of the residential complexes. Some need green tariff, and already the government is inserted this green tariff, and probably this may come into the picture. And the future directions on the renewable energy integration research are as listed, which requires more analysis of the system stability and the integrity, grid protection studies to be analyzed, because we used to practice with the larger grids and the larger generation and the integration. Grid technical standards should cover technical feasibility as well as specific location of the renewable energy. Formation of number of small grids and making them strongly interconnected. Again, this is going to be an research area in near future. Formation of renewable energy management centers for proper R&D. So probably like load dispatch centers, particular locality or the particular region is going to have its own renewable energy management systems or the centers. Need of fiber optic communication for real-time information and monitoring and control without any outages. Analysis of the issue of supply unbalancing. So probably if more number of distributed generators are going to penetrate, means probably the unbalancing is going to be there. Transformation of microgrid system today into the intelligent, robust energy delivery system in the future by providing significant reliability and security benefits. So probably the security is a major threat when it comes to the distributed system. Probably that will be taken care by the research in the near future. To investigate full-scale development, field demonstration, experimental performance evaluation of frequency and voltage control method under various operation modes. Because if we are relying on the renewable energy sources, probably the maintenance of the frequency, voltage, and the power quality is definitely a challenging one. Probably, which may be looked or solved by the researchers. So together, shaping the future of electricity and shaping the future of the globe, and we are going to pave the way for the better living for the next generation. So probably the global warming and the greenhouse emissions may be reduced by if we are adopting the microgrids at the particular locality or at the particular facilities. And probably these are the deliberations related to the renewable energy integration with reference to the microgrids. There is any questions we will discuss? Audience, any queries? Vijay Bhaskar sir.
Sir, சொல்லுங்க. Kumar Chinnaiyan sir, tell me.
Sir, if there is any questions,
Sir?
or are there any questions?
Audience, any questions you can ask please now. Participants, any questions please you can ask now.
Yeah, or else we'll wind up, sir.
Okay sir, okay. Participant, if you have any questions you can ask now, otherwise you can wind up now.
I think we will conclude, sir.
Okay sir, okay. Okay, thank you sir. Thank you Professor Kumar Chinnaiyan
Okay,
sir,
sir, thank you.
for your wonderful presentation regarding renewable energy integration. Thank you sir, thank you.
Thank you, sir. Thanks for the opportunity. Thank you, participants. Have a good day. Thank you. Bye bye.
Okay. Thank you, participants. If you have any queries, you can leave. Okay, we will meet tomorrow morning, 9:45 a.m.
Okay, Professor.
Okay,
Thank
thank
you.
you.
Bye bye. Thank you. Bye.
Okay, thank you. Thank you, Kumar. Sir. You can leave, sir. No problem.
Okay.
Participant, feedback will be sent to your chat box now. You can fill it up and send it to us. Okay. So you can go to participant. You can go and see your chat box now. The feedback is available. You can fill it up and send it to us. Thank you. After the completion of your feedback, you can leave. So we'll meet tomorrow morning, exactly 9:45. Thank you. Thank you.
இன்னும் டவர் கிடைக்குதா